Uh, Good morning, my YouTube viewers. Crystal here. What I wanted to do this morning is I wanted to give you a solution to the analytics VidHaya mobility analytics contest question. And the top score in this contest question was 70%, and I scored 69% on this solution. So it's a good solution. It's not a winner, but it's a very, very high placement. So it's a very good solution. So I want to take you through this solution so you'll have a better understanding of mobility analytics. My solution is on GitHub, so you can see my name, so you can look me up on GitHub. If you want to follow along on GitHub with the solution, you're more than welcome to do that. The first thing I did was I imported my libraries. I just imported all the libraries that I thought I would need and left it at that. And then the next thing I did was I imported my files. My files are stored on GitHub, so if you want to use the train test and sample submission file and not have to save them on your hard drive of your computer, you're more than welcome to use them. That's why I saved them, so other people as well as myself can use those files without using up memory on their computer. Next thing I did was I set up my scalars, and although I didn't use all of them, I did actually set them up in case I needed to use them. It's always a good idea to check your answer with your scalar and check your answer without your scalar to see which accuracy you get best. And I've been studying some more on scalars. They've got all kinds of scalars you can use, so I will be experimenting with other scalars as well in the future. So we've got our train file. You can see our train file is a mixture of integers, floats, and strings. So basically what we have to do is we have to convert as many of the columns as we can to integers. That's what we have to do. And in addition to that, you see we've got some null characters, not a number characters. We have to convert those two characters, have to convert those to values as well, because the system won't accept not a number values, so it'll definitely decrease the accuracy in the best case scenario. You see your test file, which is the same format as the train file, except for the fact that it doesn't have the surge pricing type. Now, the surge pricing type is going to be 1, 2, or 3, which means that you won't be able to use it for binary. You can use logistic regression, but you won't be able to use it for binary. You'll have to use like multi-soft to get it. We've got the sample submission, and the sample submission tells you the format that Analytics VidHaya wants to see it. And I can tell you that if you don't have it, even if you have like the trip ID isn't right, Analytics VidHaya won't accept it, because I found that out. We have information on the train file, and it tells you which columns are objects, floats, and integers. And the goal is to have as many columns as possible to be integers. That's the goal. We have the test file. Test file is the same format as the train file, except for the fact that there's no surge pricing type. We did an is null on the train file and the test file, so we found out which columns have null characters. Now those null characters have to be replaced with something. Otherwise the program isn't going to work, or it definitely won't work very efficiently if you've got a lot of null characters. So what we did was we filled up our missing values, and what I did a two-stage process. What I had to do was I filled out my missing values with the mode, and mode seems to be like the most common value. That's what I found out. Mode is like the most common value. So I filled out all my missing values with mode, except for the float here, which is lifestyle index, and I filled that with median. And then after I completed the program and I had all of my missing values taken care of, then what I did was, when the program was complete and the program was running, I went through on the train file, and then I saw the different outcomes on the train file. So I substituted values in the type of cab file. I substituted type values in the type of cab file until I got the highest accuracy. And then when I got, not necessarily the highest accuracy, but until I got an improvement in my accuracy. And when my accuracy improved, I stopped. I did the same thing with customer since months. Instead of the mode position, what I did was fill NA. And so what I would do is I would fill it with the most common outcome. And if I got an improvement, then I just stopped. So there's a possibility I could have gotten a higher score, but as soon as I got an improvement, I stopped. The median, I left it at median because there were lots and lots of values, and I didn't know which value to select. So on lifestyle index, I just left that at median. Confidence lifestyle index, and again, what I did was I just substituted the different values that you could have until I had an improvement in my score. And then when I had an improvement in my score, I stopped. So in theory, I could have kept on going until I got the highest value, but I just waited until I had an improvement, and then I just stopped. Ver1, I just put the mode value down, and mode is like the most common value. And the reason why is because there were so many Ver1 values, I didn't know which one to pick, so I just left it at mode. But, in theory, there could have been a value that would have improved the score, but I didn't know what value that was. I've got some blank rows in here. I don't know how that happened. It may have happened as a result of me converting the file to a format, to an IP file, to a format I could use to put it on GitHub. I'm not sure, because I don't really remember having any blank rows when I did it. The next thing we have is we're going to convert the floats to integers. So all of the floats that could be converted to integers, I did convert them to integers. So I converted customer since months and Ver1 to integers. So you see customer since once, it can be an integer, and Ver1, it can be an integer. Everything that could be an integer, I converted to integers. Did the same thing with the test file. Did the same thing with the test file. And then when we finished replacing all the null characters, I went through and checked to see if there were any more null characters, and no, there were not any more null characters. And the next thing we did was we did a group by on surge pricing index to see how many values we got for each number. And then what I did was I did a chart on that, because it's a lot easier for people to look at a chart than it is for them to look at a bunch of numbers. And you can see that they had number 2 was the highest, number 3 was the second highest, and number 1 was the third highest. But we still had, even though you didn't have a balanced outcome, I decided not to use SMOTE, because I don't really find SMOTE to be increasing the accuracy that much. And I feel that we had enough values that the train file could pick it up. So I didn't put SMOTE in there. I was just worried that it was going to decrease the accuracy, and I didn't want that. So we did a group by on trip distance, and you can see that the distances are, 10,326 values. I personally didn't know what to do. I suppose that if I wanted to, I could say, well, everything up to 10 miles is short, and 10 to 50 miles is medium, and everything over 50 miles is long. And I could have established some bins and done that, which I could go back and do that and see if it improves my score. But I didn't do that. I just left the distance as it was. But the more manipulation that you do on a file, the more chance for error that you have. And I just decided in this instance to leave it as it is. We did a frequency on it, so you can see that most of the distances were, 30 miles. That was the most of the distances. The next thing we did was we did type of cab, and so you have 5 types of cabs. And I did a chart, and number C was the most prominent type of cab that they used. So we used label encoder to label encode the cabs to give you a numeric value for each type of cab. And so you can see we've label encoded it. The next thing we had was we had customer since months, and we did a group by on that. And I put that on a chart, and you can see that the highest customer since months is 10. The next thing we did was we did a lifestyle index. And I did a group by on that. So you can see the lifestyle index had 55978 possible outcomes. And I did a violin chart on that. And you can see that the lifestyle index was a group from 0 to 5, or 1 to 5 really. And I decided that since it was 1 to 5, this was something that I could convert to an integer. And I decided to go ahead and convert the lifestyle index to integer. Which I suppose if I wanted to, I can go back to the distance and convert that to integer as well. Yeah, and if I convert the distance to integer, that's definitely going to decrease my values. I might do that, convert the distance to integer, and see if that improves my score. So I converted your lifestyle index to integer, and then I did another group by, and you can see instead of all these thousands of outcomes, you only had four outcomes: 1, 2, 3, 4. And then I did a chart on that, and you can see that number 2 was the highest value. And the next thing I did was confidence lifestyle, ABC. I did a chart on that, and so you can see C was the highest value. And then we had to put that on a label encoder. When we put it on a label encoder, I did another group by so you could see it, 0, 1, 2, and you can see number 2 was the highest lifestyle indicator. The next thing we did was we did the destination type. So that goes all the way from A to N. And then I did a grid on the destination type. And so you can see type A was the most used type. And I put destination type on a label encoder. And I did destination type again. So you can see that instead of characters, you had numbers, which is what the computer wants to see. We did customer rating. So this had a lot of values as well. We did a violin chart on customer rating. We converted the customer rating to integer. And you can see we have a new customer rating anywhere from 0 to 5. So now we have a chart on the customer rating, and you can see that 2 and 3 were almost equal. We had cancellations the last 1 month, and so you can see we had 9 different choices to select from. And we did a chart on that, and 0 was the highest choice. Next thing we did was var1, and var1 is an anonymized listing. And so because it's an anonymized listing, there wasn't much I could do about it. So I just left it as it was. But I did a violin chart, and you can see most of the var1s were between 25 and 50. We did var2, which was an anonymized listing. So there was not a lot I can do with it since it was anonymized. And we did a violin chart, and we can see most of the values were from 40 to 60. So that's about 50. We did var3, which is in another anonymized chart. And we did a violin chart on that, and most of the values were between 60 to 80, so that makes it about 70. We had a gender column, and you can see most of the taxi drivers were male. We put it on a chart so you could see that most of the taxi drivers were male. We put it on a label encoder to turn it into a digit. And then when we were finished doing all that processing, what we did was we just checked to see if we had any null characters. And no, we did not have any null characters after we did all that. So you can see train info is all integers except one object and one float, but we won't be using the object for the calculations. And the float, what I'm going to do is I'm going to go take that float and turn it into an integer and see if it improves my score, because I think that's one thing that I can convert to an integer as well. So you can see the train file, and you can see everything as a numeric, which is what the computer wants to see. It wants to see numbers. So we created a heat map so you can see how the surge price index relates to all of the other independent variables. Because your surge price index is your dependent variable, and the other variables are independent variables. You can check your train info. Again, you can see information, which I didn't need to put it there. I could have deleted it if I'd wanted to, but I needed to set up my features. So I had to see the train info so I could set up my features. And your features are every column except surge pricing and trip ID. Your surge pricing is going to go into train labels, and it's going to be reshaped. The next thing we do is we set up our X and Y variables. So your Y is your train labels, which is surge pricing reshaped. Your X is get dummies train features, which your train features is what I've set up here. And your X test is get dummies test features. I left the standard encoder in there because generally you can check your accuracy. You can see if your accuracy is better with standard encoder or without standard encoder. So it was left in there, but I didn't use it. We split our training file into four different categories: into train test, train validation, Y test, Y validation, using train test split, using X, Y. We had a test size of 0.1 because you want to have as much training data as possible, because if you have more data, then it's going to increase your score. We use XGB, and we had to use multi-soft problem to use the XGB because you had 3 different categories that your answer could be in. We fit the model, and then we predicted the X validation, and you can see we had the different columns there. So you fit the model with X train, Y train, and we predict the model on X validation to get a Y pred. And then so we check our accuracy, which is 69%, and 69% is the accuracy that I got on the solution checker. And when I checked my solution against the leaderboard, the highest value was 70%. So I was only 1% less than the highest value. So that meant that I did a pretty good job of processing the data. We checked our F1 score and F1 recall. It was 68 and 69 respectively. We prepared a matrix so you can see how many values you got of each character or each digit. We did another column to see how many you got of each digit. We did accuracy statistics to give us a 69%. We checked pred as a prediction on X validation, which I didn't need to do that because I'd already done that before, but it's in there. We checked our accuracy score, which is 69%. X validation we flattened X validation and pred. And then here's your outcome. So you can see the predicted value against the actual value. And then your prediction is a prediction on X test. So we made the prediction an integer, which it was already an integer, but I put an integer in there just for best practice. And then there's your output frame against your trip ID and your surge price. And you have to make sure that you put trip ID in there, because if you don't put trip ID in there, Analytics VidHaya won't accept it. I know it because I wouldn't accept it when I didn't have trip ID. You create a CSV file with your data frame, and you get a little message that said your submission was successfully saved. And then you load your submission. And then when you load your submission, I did mine on Google Colab. And when you load your submission, you can download it to your downloads file. And then when it's downloaded to the downloads file, you can go to Analytics VidHaya and you can input it into Analytics VidHaya, and that will what shall we say, that you can test your score on that. And then I checked my score against the leaderboard, and I was only 1% lower than the highest score. But what I'm going to do is I'm going to go make my trip distance an integer and see if that improves my score. Maybe I'll get a 70, who knows? And if I get a 70, then I will input my solution onto the website so people can look at my solution if they want to. So that concludes this presentation. If you like my solution, then please like, subscribe, and share. And if you like like my video and you like the work that I do and you want to make a donation, I've got my email address to my PayPal account down below. The reason why is I don't have enough subscribers, so I can't monetize my videos. So the only way I can make any money on my videos is to ask for donations. And thank you so much for watching this video to the very end, and I look forward to making the next video for you.